Welcome to lesson 2 of chapter 3, Matter and Energy. This lesson will cover sections 3, 4, and 5 of the chapter. Section 3 of chapter 3 is on temperature. And as I'm sure you're well aware of, in America we use the Fahrenheit temperature scale, but that the rest of the world uses the Celsius scale. In the sciences, though, the whole world uses ultimately the Kelvin scale. And the reason is that the Kelvin scale is an absolute scale, meaning that its numbers, its values are always positive. You can go outside on a winter's day, let's say in Canada, and experience negative degrees in Fahrenheit in Celsius. But what you can never do is get a negative temperature in Kelvin. Absolute zero is just the lowest possible temperature. It's a theoretical limit of temperature where it's zero. Now, let me put this into perspective. If you were to try to measure the length of an object, let's say a pencil, you can't measure it in negative centimeters or negative inches. It's got to have some positive value to it. Same thing with your weight. You can't weigh negative pounds or negative kilograms. You have either zero weight or more. And the same thing must be true for temperature. And so that's why we use the Kelvin scale. When we get later on into this class, you'll see where when we use calculations that involve temperature, that if a negative value is used, it won't work. So what I need to state here is that a change in 1 Kelvin is exactly equal to a change in 1 degree Celsius, because the Kelvin scale was based on the Celsius scale. So as you can see over here, if the Celsius scale is reading 0 degrees Celsius and it changes up to 100 degrees Celsius, that's a difference of 100 degrees Celsius. Okay? Now, if I do the same thing at the same exact amount of energy in the system, in this water, right there, it says 273 Kelvin. If I heat that water up by 1 or to its boiling point, just like I did with this water over here, you'll see its temperature is 373 Kelvin. And so 373 minus 273 is 100. It's exactly the same. Now, if we go backwards, we go all the way down to where that's at 0 Kelvin. That will go down to negative 273 degrees Celsius. The real value is negative 273.15 degrees Celsius. That is absolute zero. We will not worry at all about the Fahrenheit scale in this class. The equations I have shown here show you how to convert from one temperature scale to another. So, for example, the first one up here, you would use this if you were trying to convert from Celsius to Fahrenheit. So I could write it as what you want on the left here, and that T sub C is what you're given. Temperature in Celsius. Temperature in Fahrenheit is what you want. Same thing for that equation, it's TC, TK, TC. Always on the left of those are what you're wanting to find, what you're given on the right. All right. So question 1 here, what is body temperature in degrees Celsius? Well, we know that the temperature of a body is on average 98.6 degrees Fahrenheit. Like I said, you won't really use Fahrenheit on your tests, but I do want to show you how to use these equations. So you have 98.6 degrees Fahrenheit. In order to convert this to Celsius, we have to use one of those equations on the previous slide. So we're going to say T sub C is equal to the temperature in Fahrenheit minus 32 and times 5/9. We substitute 98.6 into that, you get this equation here. 98.6 minus 32 is 66.6. Multiply it by 5/9, and you get 37 degrees Celsius. So body temperature in Celsius is on average 37 degrees Celsius. That is what the rest of the world knows body temperature to be. So this second part of the question asks you to put that body temperature in Kelvin, and so you would use the equation here, where temperature in Kelvin is going to be equal to the temperature in Celsius plus 273.15. So we substitute everything into there, and we have 37 plus 273.15, and you get 310.15 Kelvin. Question 2 there says, what is the boiling point of water in degrees Celsius and Kelvin? So the boiling point of water, if you happen to know this, is 212 degrees Fahrenheit, but I think it's more commonly known to just be 100 degrees Celsius, because you know what, it makes sense. So I'm going to use that, and just, what is it in Kelvin? All you need to do is add 273 to that. So we get 373.15 Kelvin. Don't forget the units. The last question there says, at what point are the degrees Fahrenheit and the degrees Celsius equivalent? So that's saying the temperature in Celsius will equal the temperature in Fahrenheit. Now we can do this pretty easily by just taking one of those earlier equations on the previous slide. Let's say the temperature in Celsius is equal to the temperature in Fahrenheit minus 32 times 5/9. Okay, and since we have this relationship right there, I can substitute into here T sub C in for the T sub F. Since they're equivalent, it doesn't matter how I write it. So now I have that. Alright, and then I need to simplify this equation. And so I need more space, so it's getting smaller and smaller in there, but we have T sub C equals 5T sub C divided by 9 minus 32 times 5, which is 160, and then it's divided by 9. And I have the T sub C on the left side of the equation. I've got the T sub C on the right side of the equation. I want to put them on the same side in order to isolate that temperature in Celsius. Now, so I'm going to subtract 5/9 T sub C from each side, and that will yield T sub C minus 5/9 T sub C, and that will equal negative 160 divided by 9. Since I have 1 TC and I'm subtracting 5/9, ultimately that's going to equal 4/9 T sub C, and it will equal 160 over 9. In negative, there, can't forget the negative. We have 9 on each side, so guess what? They cancel out. That leaves us with 4 T sub C equals negative 160. Divide each side by 4, and you get T sub C equals negative 40 degrees Celsius. Since we already stated that T sub C equals T sub F, that means that T sub F is also going to be negative 40 degrees Fahrenheit. They're one and the same at that point.